Good morning, students. Today we are going to see about the implementation of linear regression, regression, and logistic regression, right? So we have seen about the PPTs, and now we are going to see the detail about the codes, how we are going to run, okay, in the collab, right? Okay. So here we are just importing the NumPy for numerical and then import pandas, okay, for importing the data frame and then import matplotlib, okay, for visualization process, right? Okay. So for that, I'm just taking first implementation of the linear regression. Okay. So as you know, for the linear regression, you have to have the line equation. Okay, so that we have to find, and also that will be the finding the line equation that will be the predicted output, right? So for that we are going to find that. So for that we are having the CSV file that is salary data. Okay, so for linear regression, as you know, you will have only two columns. One is you will call it as like an independent variable, and another one is a dependent variable. That's why we can see in this particular thing, that is when you go for extracting, okay, x and y columns as numpy arrays, in which you can see that x and y as a variable we are taking, and in which we are going to take the zeroth row, okay, so our zeroth column, that is the independent variable, okay, and then we can see this one is a dependent variable. So we are calculating the mean value of x and y, that is x mean and y mean. Okay, so x cap and y cap, we will use it in the formula, right? So this is like a predefined function. We are calculating the mean for the x column and the y column, what we have taken, right? Okay, so for that, you will have like, okay, when we are going to apply in the formula, okay, to find, for that, first we have to initialize the numerator and the denominator. If you want to know more about it, I have shared the PPT in which I explained about the linear regression, okay, multiple regression, okay. So in PPT format, there I have explained about all the equations, how we are going to calculate. Here I am just telling you about how to give that equation in the code format, right? Okay, so for that, first we have to initialize the numerator and denominator as zero, so that in each and every column you will have the values of x and y, right? That have to be taken one after another. So first, when we say the numerator, which is sending through the for loop, okay, in which the I, okay, ranges up to the length of x, okay, and then we are giving the numerator and denominator as we are initialized that we are giving it as like numerator equal to numerator plus, we are giving the xi value minus x mean, okay, that we have found out in the previous formula, predefined function we have found out, into yi minus y mean. Okay, so that is the formula, right? And denominator we are going to take xi minus x mean the whole square. Okay, so this is the formula for numerator and denominator that have to be passed on to the for loop for each and every value of x and y. Okay, so that is how we are finding out. And then for calculating the slope, okay, that is numerator by denominator. So normally in the line equation, we have the slope also, right? For example, y equal to mx plus c. Likewise, we will see the mathematics that in which m is the slope, right? Okay, so that is how we are just finding the slope. Here we are using the parameter as a1, right? Okay, so calculate the intercept now, a0. Okay, so we have a slope and we have the intercept, and then we have the x and y value, right? Okay, so how to calculate a naught, that is intercept, which is equal to y mean minus a1, which is already find, okay, the numerator by denominator we found, right, into x mean, that also we have found through the predefined function. This is the formula we are using to calculate the a naught A1, right? So after finding the A0 and A1, we can calculate the prediction. Okay, so as you know, YPRED is after sending the training, okay, the new data when it enters, we are going to predict the value, right? So that is how for the line equation, as I told you, the predicted line. Okay, the predicted one you will get, and according to the data sample what we are given in the data set, it will be plotted, and then we are going to make a line that will be like y print. So the difference between the original data point and this y print will give the error rate, right? So that much we can say which is the best fit, right? Okay, that is how we will calculate that. I explained already in the theory. If you want, you can just check the video of it, right? Okay. So calculate the performance metrics after drawing the finding the slope and intercept and then y-pred also. Okay. So then after finishing this process, we have to go for the performance metric as well, right? So MSC, that is mean square error, we are calculating. Okay, that is NP is the package dot mean of y minus y-pred square, right? So that is how we are finding out. In formula, we will use instead of y prime, we will give y bar, right? Y minus y bar, the whole square. Likewise, we will use the formula for finding the MSC, right? And then RMSC, that is root mean square error, right? So that is NP, that is the package dot square root of MSC. That is how we will do it. And then R square, that is the next performance metric. So for that we are using two variable, that is S total and SS residual, in which we are first calculating the sum. Okay, that is numerator. We are taking the sum of y minus y cap, that is y mean the whole square. That is how we will put in the numerator, and in the denominator we will put like NP dot sum of, you will put like y summation of y minus y pred. Okay, that is y bar, right? The whole square. This is how we will put, right? So when we calculate the R2, right, that is R square, that is equal to 1 minus this numerator by denominator, SS total by SS residual. When you put, you will get the R square performance metric. This is how we will calculate. This is also, all these things are the formula to find the performance metric. So we, in the code, okay, coding, how to give, that only I'm just explaining, right? And now after finding all these performance metric, we have to print it. Okay, for that we are just printing MSC, RMSC, and then R square. All these performance metric we are printing. And finally, we are going for the visualization, that is plot. Okay, so that's why I am just with the package PLT dot scatter. Okay, in which I am giving X, Y, and the color of okay, plotting, which is giving it as blue. Okay, so just plotting the data point. That is the original data points. What is the value between the X and Y plane? Just I am printing with the blue color, right? And again, the best fit. Okay, so for that I need Y print. Okay, I have calculated already the Y print, right? So that we are making it as like a line, best fit line, that should be in a red color. Got it? So when we will say the red best fit line, all the value it will put, and which has the less error while putting the y equal to mx plus c, that will be considered as the best fit line. When you see the graph, you can see, okay, so this is the y pred, and all these blue dots, we will call it as like the actual value, okay, the data points, right? So we can see that this is the best line fit because this is like only the minimal distance between the original data point and this y pred. Got it? So that is how we are just making the linear regression. Okay, simple linear regression. Coming to the next category, that is multiple linear regression. Instead of having only one independent variable, here you will have multiple independent variable and one dependent variable. That's the difference we will see in the multiple linear regression. Okay, so here also we are importing all the library and NumPy, and then for visualization, and this is for the numerical data, and this is for the data frame, that is pandas, and then we are importing the 50 startup. Here what we are going to use the CSV file is startup. Okay, so in which the different parameters we are using, and finally the target will be we are calculating the profits, right? So that is how we are going to have the data set, right? So for that, first I have to locate the X and Y. Okay, so how we are giving it as like for independent variables means not the last dependent variable, except that all that have to be made. That's why I'm giving colon minus one. And I'm giving like this means instead of taking the last, okay, column, the remaining all the column like that, it will be taken it as X and Y is the target variable. That's why I'm giving minus one directly. Got it? So that is how I'm just taking the Y, that is the dependent variable, right? And then I'm printing everything, right? And then I am encoding the categorical data. Okay. So I am doing this for that. I have to take from sklan dot compose, okay, in which I have to import the column transformer. Okay, so here we are using the one hot encoder because there will be some particular field. For example, you will have like so all that thing will be numerical value, and some column will be like state. Okay, if it that it is given in startup, right? So state means it can have three categories. One can be like New York, and another one can be California, and another one can be another place. Got it? Japan or something else. So if you are having all these things a numerical variable, so one hot encoder, as I explained already in the theory part. So here how it will do is it will make it as like a three different columns. 0, 0, 0, and the first row will be like New York, and the second column will be like okay, the next California or something, and then the third can be Japan. And which one it actually, okay, the first state, if it talks California means the second column will be marked as one, and the remaining thing all will make it as zero. And the next, okay, row, if it says it is a New York, the first column is New York, right? So the it will be make it as like one, and the remaining other two will be make it as zeros. Likewise, we will convert, okay, the numerical, sorry, the categorical data into the numerical by means of one hot encoder. That is how we are just doing it by giving the predefined, okay, this code, you will get it, right? Okay, so that is how we are just encoding all the categorical data, right? And then after making all this in the pre-processing, what we are going to do is we are going to split the time and test data. Okay. So we are giving zero point 0.2. So 20% we are taking as a test size, and the remaining 80% we are taking it as a training samples, right? Okay. So training the multiple linear regression model. So for that, I have to just give the linear regression, okay, function. Here I'm not going to, I'm not using y equal to mx and finding the y spread and so on. Here directly I'm using the predefined function linear regression. Okay, so this is the thing also you should know, right? Okay, so that's right. I'm using the variable regressor in which I'm going to pass the predefined function linear regression. Okay, so regressor dot fit in which I'm going to fit all these x train and y train. Okay, so for x train samples you will get, okay, so y train will be the outcome. Similarly for x test, you will have the y test will be the outcome, right? Okay, so that is how I'm just fitting, right? And now going for the test set results. Here also I'm just giving x test as the input, right? And then here I'm making it as y pred. Okay, so x test for that normal, okay, original value you will get it as like y test, but y pred is a predicted value. Okay, so that's why I'm passing the predicted value, and then what I'm doing is I'm going to concatenate this predicted and with the y test. Got my point? So that is how I'm going to show the result. So actual test result what it is, and the predicted result what it is. So if both are similar means, then I can say this model is perfect for the data set what we have uploaded. Got my point? So this is how we are going to finalize it. When you see um, in this output, you can see that at the end, you can see that both the thing. Okay, this is y pred, and this is like the whitest. Okay, so you can see the difference. More or less, both are similar. Got it? Only small difference in it. So I can say that the predicted output is the best fit. Okay, I got when I compared with the whitest. Got it? This is how they will compare it. That's why I have concatenated both the widespread value and the whitest to show our model is perfect, right? Okay, this is how the multiple regression will be done. And finally, the logistic regression. Okay, so as I told you, this is not actually the regression. It is like a actually it's a classifier only. Okay, but the name only we will call it as like regression. Okay, so it is actually classifier, right? Okay, so let us see the code how we are going for the logistic regression. Here also we are importing all the libraries NumPy, Matplot, and Pandas. Okay, initially, and then I'm going to import. Okay, the social network ads. I'm going to get it. Okay, so that is the CSV file I'm giving inside. Okay, and then I'm going to here also it is like a multiple regression in which you will have many independent variable and one dependent variable. That's why I'm giving colon -1. So it will take all the independent variables as put it into the variable X, and then only the target or the last column. Okay, take it as like a that is the dependent variable that have to be make it as y. Okay, and now I'm going to split again and like in the previous technique. Here 25% I'm giving the test size and the remaining 75% as the training sample, right? Okay, and then I'm printing x train and y train. That means x train the outcome will be y train, and x test the outcome will be the y test. Okay, this is actually after splitting I'm just making to print x train and y train, and X test, the corresponding result will be the Y test. And then coming to the next, that is feature selection, I'm going to do it. Okay, what is this actually feature selection? It is like normalization. Got my point? Okay, so normally we will use the standard deviation and variance. We are using this formula and we are going to normalize it. Okay, the each and every input minus some sigma divided by some standard deviation. Likewise, we will give y means we are just making it into the feature scaling. We have to do it, that is normalizing. For example, if the age and salary, the difference between this numerical value is high. Okay, when you just make an analytic in which if it is not normalized, then that leads to confusion in when you make an analytics in it. So if you normalize such numerical value into the common thing using such formula, we can get the accurate result. Okay, so that's why we are using the feature scaling. Okay, by using by fitting. Okay, and then fit transform, and then we are printing the x train and the x test. Okay, so that is the input. Okay, and then training the logistic regression model on the training set. Okay, so how we are going to do here, I'm just giving the classifier. As I told you, this is not the regression type, it is just a classifying what category it belongs to one particular thing and the another one. That is how it is going to classify. Okay, so here in classifier, I'm giving the X train and Y train, I'm just passing it out. Okay, using the logistic regression function. Okay, so here predicting a new result. Okay, so consider a new value which inserted in is 30 and 87,000. I'm just going to pred. Okay, finding the predicted result. Okay, that is y pred. Okay, so normally y test you will get it, and now I'm finding the y pred for it from the x test as an input. Okay, so X test as an input. So after that, I'm just making to concatenate. Got it? Concatenate, as I told you in the previous multiple regression also we have seen, right? This Y pred and Y test, I have to concatenate and I have to just check whether both value is similar or not. Then I can say this particular classifier or a logistic regression is fine with the model. What this model is good for the given data set. Likewise, I can just give the okay, outcome, right? Okay. So for that, I have to find, after doing this, I have to check the performance metric. So for that, first we are making the confusion matrix in which we are going to find the true positive and true negative, right? So how much it is. Likewise, we are going to find the confusion matrix, okay, to tell the performance. And then the accuracy score. Okay, so that is also we are finding out for the white test and the white spread. Okay, so that we have calculated, right? So for that confusion matrix I'm putting, and I'm just comparing the value of white test and the predicted value, and here the actual value and the predicted value for the accuracy score function, just we are passing it out. Okay, and then finally we are going for visualization. Okay, as you know, for visualization, okay, so that is just I'm going to visualize the classification how it is happening. Okay, so we are making the red and green as a two, okay, area, and I can see the plot also in different colors to show that how much, okay, the model which is perfect. Okay, so logistic regression, in which I am going to give it as like a title, in which I am just giving the training set age as X label as age and Y label as estimated salary and title as logistic regression. Okay, and then I'm just going to show the result. Okay, how this red and green, which is classified, and how the data points you will collect it at the end. Okay, so similarly for visualizing the test set result. Okay, so how we are going to visualize the test set result. So here also we are going to just find the age as the X label and Y label as the estimated salary, and I'm going to show the result of it. Okay, so this is the test set result, and this is the training set result. Okay, so both result, okay, we are going to just visualize. When you see here, you can see this red and green, okay, in which the different data points, okay, which is fit in, okay, and then we have fitted, right? So this is how I can just classify the two categories, okay, by using the logistic regression. Okay, so it is completely a regression model. It is not based on the like a line diagram. Okay, we have drawn, and then through regression we are finding out the actual point and the predicted point difference and all we found, right? But here it is completely the classifier. It is classifying the input data. Okay, so new input data when it enters also based upon the classifier we made already, it will going to fit in. Okay, either to this side, okay, right side, that is green side, or to the red side. Likewise, it is going to decide. Okay, so I hope you understood the three categories of, okay, implementing the simple, okay, regression and multiple regression and logistic regression. Okay, so try the code, okay, and then easily you will get it. Okay, all the best. Thank you. We will see with the next topic, the next video. Thank you.